So I want to look at graphing complex numbers and polar forms of complex numbers. So just real quick here, when we're used to plotting points and graphing, you're used to doing X and Y. Okay, like for example, if I did 2 and 3, I would go right 2, up 3, and plot a point. For phasors or vectors, however you want to call it, we kind of do the same thing, except this is your x-axis and here is your imaginary or your j-axis. So a lot of your numbers are written maybe like this: 2.00j minus, or let's do minus 5. Okay, so this looks nothing like this point, and it's kind of backwards. Really, this is more like -5 plus 2j. So what I do is I go left 5, up 2, make a point. Okay, and eventually we draw the phasor at that point, okay, or the vector, however you want to call it. So when you're plotting points, the J point is your Y. The other one is your X. So it works the same way. You do the X and the Y, and then you make your point. And in this case, we can look at a drawing, okay, or a vector. So that's how to plot points. Now, let's look at the polar form. So you might have, and I'm pulling these to make it look like kind of what your book has. But you might see something that looks like this. Okay. And they give you multiple choices as to where it is. Okay. So if I'm looking at this point here, 6j minus 8, again, this is your x, this is your y. So I go left 8, up 6, and then your drawing is going to have an arrow there. Well, this right here, the 6j minus 8, is what we call rectangular form. Okay, rectangular form. Now, to convert that to polar form is basically the magnitude of this phasor or vector and the angle of rotation. Okay, and the angle of rotation kind of always begins in the positive quadrant and goes counterclockwise. Okay, so the way I suggest doing this, to me, is to kind of, take this phasor off of the grid and then recreate a right triangle similarly to what's drawn over here. So in other words, this right here is +6. This right here is -8. Okay. Now, we can use our Pythagorean theorem to find this side right here. We'll call this R. Okay, so that's our hypotenuse. So R is the square root of 6 squared plus -8 squared. Make sure you square that negative to make it positive. What you should end up with is square root of 100, which is 10. Now I want to give you a second to calculate that to make sure you're typing it correctly into your calculator, because that's where most of the mistakes happen. Okay, hopefully you got that all worked out. So now that's my R. So then we have to figure out, okay, what this angle is here. Okay, what this angle is here. Well, from here all the way to the end is 180 degrees. Okay, so what I'm going to find out is what's this angle here in this triangle. Okay, then I've got to do an adjustment. Okay, now if it's in the first quadrant, it's whatever the angle is. It just depends what quadrant it's in, it can change. So if I can do, whatever trig equation I want to, so if I want to do the sine of theta, okay, that's going to be opposite over hypotenuse, which is 6 over 10. Sine of theta is 0.6. So then my angle is sine inverse of 0.6. Do that in my calculator, and I get 36, theta is 36.9. If I round it to the tenths place. Okay, but that is this angle here. Okay, that's from here to here. So what I do is to find out the total location of this phasor, I take 180 minus 136.9 and I get 143.1. I know this can be a little confusing. Okay, it can be a little confusing, but that's kind of what we have to do because, see, I know that this is the angle of the triangle I've created, but what I really need to do to locate this phasor is to pretend I'm rotating it all this way. So it's this angle taken away from the 180, which would be the whole half of the grid. Okay, it's a little confusing, I understand that. So now my polar form, the 6j minus the 8.00 is going to be my R times my cosine 143.1 plus the sine 143.1. And I know that's a little confusing, okay? May not be easy, but I think you can figure it out. You just may have to do it a couple other times. And then one thing I did forget here, we always got to put the J in front of the sine. Sorry about that. Okay, because your cosine is your X, your sine is your Y. So we always want to indicate, since we're dealing with phasors, we want to keep the J value there. Okay, it is confusing. I understand that. I totally understand that. It may take you a few times to get this down. And the J sometimes may go after the 6, after the number. Sometimes it may look like this, J6 minus 8. Okay. I apologize, but that's just what they do. Okay. That's just what they do. I don't have control over the way they create their questions. But the only thing I can do is, give you as much heads up as possible on how to calculate this. Now, there are videos as well, in the other part of the class where the regular videos are. So you can certainly watch those for extra instruction as well. So I'm going to stop here and, just do your practice. Make sure you're good at the Pythagorean theorem. I gave you some practice problems for it. And take care of all that.